Hi guys, it's Rob from Royal Balls. A lot of questions just recently on can I breed siblings together? Can I breed offspring back to the parents? When would be the right time to bring in new blood into my collection to avoid inbreeding? I guess it serves me right for doing a lot of the genetic videos. Let me say right up front, I am not a geneticist. I'm not even a biologist. I am a scientist. I can share with you some of my observations and some of the research that I have done, but none of this is definitive, and I do encourage you to do your own research and make up your own minds. So with that in mind, I have left a series of references at the end so that you can start your own research if you're at all interested. So a couple of terms that we need to clear up right at the start. So let me show you an example of when we do line breeding in ball pythons. This is about the 5th generation of calico bumblebees produced by ARP constrictors, and yes, they are line bred. The particular qualities of this calico bumblebee, the very clean sides and the sharp contrast in the markings, has been improving through the generations. So yes, they are line bred, yes, they are indeed related to each other and will share some DNA. However, having said that, the best of these calico bumblebees are not gained by breeding back brothers to sisters. The best of these bumblebees comes from breeding the best of each generation back to the original pastel females that started this whole thing. For some reason, those pastel females throw particularly nice calico bumblebees, and the best of the offspring are bred back to those original great grandparents. So in actual fact, the amount of genetic material or DNA that's shared with these babies is actually minimal. Are they related? Yes, they are. Are they line bred? Strictly speaking, yes, they are. But by breeding back and skipping a generation or 2 generations or 3 generations and breeding back to the original parents, the amount of shared DNA is minimal. And I think you can see from this girl here that she is actually a beautiful example. She does have spider in her, which is a mutation that has a known neurological defect, but in this girl it is absolutely minimal. So she is a beautiful example of line breeding ball pythons, but sticking to those strict rules of genetics where you skip at least 1 generation. In this case, she was bred back to her great grandparents, so the amount of genetic material that's shared between these various calico bumblebees is actually quite minimal. An example of how line breeding can be done safely with no defects involved in the animal and a minimal amount of shared genetic material that may cause issues. So this is true line breeding. Now let me show you an example of where we are going to be line breeding, but not for line breeding's sake. This is a genetic variation on a clown. We call it the X clown, and this is a female. And there was another male in the same clutch, and I'll show you him in a moment because I have managed to procure him. The idea of breeding brother and sister is not actually to line breed whatever characteristic is in these animals. It's actually to prove out whether it's genetic, and what I'm trying to achieve here is not to improve the characteristics of whatever is in these animals, but to prove out whether there is actually a superform, whether it is a genetic mutation that both brother and sister are carrying, and whether we can make a superform. Is that line breeding? Yes, 50% of the genetic material in these animals will be shared. And so there is the possibility that with that amount of DNA, that any defects that are in this line with similar parents are going to show up in the offspring from this brother to sister pairing. Will I repeat that pairing? No, that isn't the purpose. I'm not trying to generate a polymorphic variation that's carried on for generations. I'm actually trying to prove out whether this is a genetic mutation and prove out whether there is actually a superform. And once I've proved out the superform, we'll be adding different genes, which means breeding back to completely unrelated snakes. And as soon as you do that for even just one single generation, the amount of DNA that is common is reduced to almost zero. So there should be no issues, provided that we get away with the first generation of breeding back. And generally in ball pythons and reptiles in general, they are not very susceptible to inbreeding issues. They seem to be fairly resistant to issues related to line breeding, but they are not resistant to issues related to mutation variation. So if this particular mutation, if the DNA that is carried by the allele that contains the genes for this particular morphological variation of the clown, if there is a small genetic defect, there's only a single copy of that defective DNA, and the other side of the allele contains normal DNA. So any neurological defects or duckbills or any morphological issues associated with that gene have not shown up in this animal. It looks perfectly normal. However, when I breed her back to her brother and produce the superform, if the brother is also carrying that hypothetical genetic defect at the same allele, we do run into the possibility that the superform will have two copies of that defective DNA, and that will show up in the offspring. And that's why superforms of genetic mutations often carry issues, because they are carrying a genetic defect in the DNA associated with that morphology. Doesn't show up in the single copy of an animal, but when you produce the superform, you're doubling up on that genetic material. You're producing an identical copy of the defective DNA on the other side of the allele, which means that you are also homozygous for that DNA defect, and that's when you start to get issues like kinking, duckbills, bug eyes, no eyes, all the sorts of issues that are known in ball pythons. So this is the female. We don't know what she is. We think it's genetic. We're going to breed her back to her brother in order to prove out whether there is a superform of this gene. It is not done for the purposes of line breeding. However, note that for the single generation, yes, most definitely, that is line breeding, as well as producing the superform of any gene that might be present in this animal. So it's a double whammy in this case, and yes, we do need to be cautious. If the results of this pairing produce some unexpected genetic anomalies or defects in the animal, we definitely will not be repeating that pairing. But as you can see, this animal itself, with only the single copy of what is producing this genetic mutation, if it is genetic, is not actually affecting the animal in any way at all. And so breeding this animal to anything else, not an issue. Breeding it to produce the superform or breeding it back to a sibling or a parent is probably not a smart thing to do if genetic defects do show up. So this is the female. We'll just have a look underneath, because you can see that the pattern on this girl here is also very strong underneath. That's a very unusual pattern for a clown morph to have. And this guy here, who is a little bit defensive, quite nippy, is her brother. And you can see that whatever is in these animals, he is carrying the same trait or the same gene as his sister. So yes, we will be breeding them back together. I just thought I'd show you that as an example of both inadvertent line breeding, but it's done to test out the genetic mutation and produce the superform of a genetic mutation, if that's what he is. You'll see that the same pattern underneath his belly there, he exhibits the same pattern as the female. So breeding these animals together will produce, if it is genetic, will produce a superform hopefully, and we'll be able to see whether this is a genetic variation and whether it is passed on to the offspring. So that's an example of line breeding which is not done for polymorphic variation to improve a trait. It's done to try to produce the superform of a genetic mutation, which is a completely different mechanism for producing ball pythons. Here is another example of a genetic mutation in ball pythons, not the product of line breeding. This is a leopard hetverclown male produced by ARP constrictors, and this guy will be breeding to this female, which is also hetverclown and is another genetic mutation. The parents of this girl here also came from ARP constrictors, but this girl's parents are completely unrelated to the leopard hetverclown parents, and so the amount of genetic material, even though they come from the same collection originally, there is no common genetic material. They are not line bred. They should not carry any homozygous DNA defects on the alleles of any of these particular genetic mutations or genes that are present in either of these animals. And so this is the commonest form of breeding in ball pythons, where we take different genes and we stack them on top of each other by selecting parents with the different genes and adding them together. And typically the parents of these morphs that are carrying the genes are totally unrelated. So generally speaking, when you breed ball pythons to produce these fantastic morphs, you are not line breeding, and none of the genetic material is common between the parents, and therefore that is why typically when we breed ball pythons and produce all these wonderful colour mutations, we're not actually line breeding. We're producing morphological variation from genetic characteristics which are passed on from parent to offspring, but the offspring are then being bred to totally unrelated animals. And so that's just the same as if animals in the wild were breeding together. Not usually an issue, and that's why all these wonderful morphs that we produce in ball python world typically are perfectly normal animals. They have no defects, no issues, no deformities. They behave like perfectly normal ball pythons, and you treat them just the same as a normal ball python. So the husbandry for a classic or wild type ball python is exactly the same as for a ball python that you might have paid $25,000 for. It is exactly the same animal. It is not line bred, and you do not need to worry about breeding it to any of the animals in your collection, because you are not line breeding. They are totally unrelated. Now, if we take genetic mutations, the other type of variation in the animal kingdom, this is when an animal has a genetic mutation, and let's say it's a pastel gene, just for convenience. So the male here is carrying a single copy of the pastel gene, and when we breed that to this half of the female, he is transmitting that copy of the gene a cross on his half of the DNA and producing another pastel animal. Now we know in some genetic combinations, for instance if this is banana, that this gene here attaches itself to a particular allele that carries the chromosome for sex. So when this gene in sexual reproduction is passed on to the other animal, it carries with it the chromosome that determines the sex. This can also be true for any genetic defects. For instance, the spider gene. Let's say that this is the spider gene and this animal is spider, so the DNA at that particular allele for spider has a genetic defect, and it is actually missing some of the DNA in this animal. So this is what causes the spider wobble, the neurological defect in spiders. And I don't want to get into the argument of whether it's ethical to keep spider ball pythons. This is just to talk about the mechanisms concerned. So when you breed a spider to a non-spider animal, when you take the spider gene, it carries with it that portion of the DNA that carries that defect. So when we move it across, it takes with it that genetic defect. So every single animal that carries the spider gene is also carrying that genetic defect. And that's why the original animal imported in the 90s, I think, went to Kevin McCurley at Nerd, and all spiders that are produced in the ball python industry are all related to that individual spider that came in with the genetic defect. Now, does that mean that they're all related? No, it doesn't. None of the spiders are likely to be related to the original parent because they've been bred so many times with pastels, with enchies, with any other combination of genetic material, none of which had common parents. So the amount of genetic material that is common in spiders is very likely almost zero. The only piece of genetic material that is common to all spiders is that genetic defect carried by the gene, which is a very, very tiny piece of the total DNA. But what that does mean is that every spider has it. It isn't always expressed, but every spider carries with it that genetic defect in the DNA that's associated with the allele for the spider gene. So every single one of the offspring that carries the spider gene carries that genetic defect. So here is our spider with the genetic defect, that is the spider gene, so it's always going to carry that genetic defect. Now, what happens if we breed it to an enchi and we get an enchi spider? Well, enchi attaches to a different part of the genetic material. It attaches at a different locus, and therefore any DNA that comes with the enchi gene is attaching itself to a different location, and it's responsible for a different part of the animal. So adding enchi to spider is not going to fix the spider defect. The spider defect is here at this allele, this address, and that's always where it resides, and it's always carried with the spider gene. And it does not matter how many other genes you add to that equation, they all attach at a different locus or different address and carry with them a completely different strand of DNA that has a completely different function. So it doesn't matter how many genes you stack onto spider, you're not going to fix the spider defect, except we know that certain genes attach themselves to the same locus. We know that vanilla and fire, for instance, we know that lesser and Mojave, those genetic mutations attach at the same locus or same address, and they carry with them DNA which is compatible between the two sides of that locus or that allele. So if we have an allelic gene or an allelic genetic mutation from a different animal that attaches at the same locus and brings with it the same genetic material on the other side of the allele, if we have an allelic relationship, we can bring some non-defective DNA to the other side of that allele. And in the case of spider, this just happens to be blackhead. And you've probably heard that blackhead and spider mixed together cures the spider wobble. Why does it do this? It's because the blackhead gene also attaches to the same locus or address as the spider gene. They are allelic when you combine them. If you breed this animal and it is a spider blackhead, you will get 50% of the offspring will be spider and 50% will be blackhead. But when you combine the two at this allele, you are providing a non-deformed copy of the genetic material that causes the spider wobble. So it counteracts it. The deformed DNA here is balanced by the non-deformed DNA on the other side of the allele. So blackhead and spider, yes, it fixes the spider wobble. When you breed, you produce 50% blackhead and 50% spider. And the 50% of spiders bred from that allelic combination will carry the same genetic defect associated with that spider gene. So the offspring of blackhead spider, the ones that are spider, will still carry the genetic defect. But the allelic parent does not exhibit the neurological defect. Spider blackhead does indeed fix the spider wobble. The problem with that is that spider blackhead looks just like a normal, as you might expect when you fill in the defective DNA and mix these two genes together. The allelic combination looks like a normal and it behaves like a normal. So you fix the neurological problem and you also produce something which looks like a normal, which is not actually the desired outcome. Why is the spider gene lethal? Well, if we get 2 copies of spider, the superform of spider, if we breed spider to spider and 1 in 4 of these animals is the superform, you will see now at the locus or address for the spider gene, when we double it up, so we're getting the superform of spider, we're also getting the homozygous form of the genetic defect that the spider gene brings with it. And a double copy of that genetic defect for the ball python concerned is lethal. It's a non-viable animal that you will produce. So don't do that. We don't want the superform of spider because you're doubling up the genetic defect and you're getting the homozygous form of that neurological defect along with the superform of spider, which is lethal. Okay guys, so those are my thoughts, my observations. They may differ to your own. As I said, you have the references that I used. There's plenty of references out there that I got little snippets from, plus my own experience and from seeing years of breeding at ARP constrictors. But it is not gospel and I may be wrong. I encourage you to do your own research. So with that in mind, thanks for watching. Don't forget to share, like and subscribe. Jump in the comments below if you want to join in the discussion, and we'll see you next time.